So today's video is on Jump Game 2. Uh, so basically, let me go through the problem statement once. You are given a zero index array of integers, a num of length n, and you are initially positioned at index 0. Each element num I represents the maximum length of forward jump from index I. In other words, you are at index I and you can jump to any index I plus j where j is in this range num psi and I plus j, which basically means that you can basically make a max. You can from I you can reach to I plus num psi. That is what is the maximum index to which you can reach from index I. And then return the minimum number of jumps to reach index n minus 1. The test cases are generated such that you can reach index n minus 1. Okay. So there is no test case such that you can't reach index n minus 1. So that's a given. And then okay, this is the problem, and they have given some examples, but I'll anyway explain you what the problem is again to a diagram. So basically you are at this point, and then you can from this point, suppose you have x here, and then from x is the value at this index. Okay, and then from this index you can jump to 1 or 2 or up to x. You can jump to any index, right? But maximum you can jump is x, right? And then you want to reach the n minus 1th index, right? That is the goal. So okay, so now they have that I have explained you the problem. Let me explain you how the solution would look like. So in order to solve this problem, we'll basically be traversing some ranges and looking at what is the maximum value that we can reach from that range of values. I'll tell you what I mean. Uh, So let me go with this example, like 23114, 23114. So we'll start with the range, and then we'll inspect all the elements in the range and look at what is the maximum value that we can reach at, right? So initially we are at index 0, right? Initially we are at index 0 and we have not taken any steps. So our steps would be still 0. Steps would be 0 because we have not taken any steps, because there is no steps required to be taken when you are at index 0 to reach index 0, because you start off at that point. Okay, so now we have to, so the initial range that we decide to inspect is from a range from 0 to 0. That means only at index 0 we are inspecting, right? And then we are getting a value of 2 here. So and then this is index 0, and then we are getting a value of 2 here. So basically we can go from index 0 to index 2, which is this, right? So let me just write down the indexes on the top. So okay, we have inspected the 0 to 0 range, and then we have figured out okay, we can reach maximum index of 2 here. So this, and then we'll check whether this 2 is the is greater than equal to the final index that we have to reach. So obviously 2 is less than 4, so it is not greater than equal to 4. So that means we need to probe further, probe the next range. So the next range will start obviously from the next index of the end of the previous range, which is this index, and then stop at the maximum jump that we were able to make, which is 2, right? Since we have only one index, we could only make a maximum jump till 2. So our next range would be this, and now we'll inspect this range to find the maximum value that we could reach. Obviously, before shifting the ranges after end of the previous range, uh, we will increment the number of steps from 0 to 1, because now for reaching the next range we have to take at least one step, right? Because even for reaching one we need to take one step. So on reaching for reaching any of these values of range we need to take one step, so we have to update the number of steps to 1, right? In practice what we do is that whenever we find the max after you have figured out the maximum jump that we can make for the for this range, it was at 2, right? Once we have figured out that maximum jump, then we know that to reach that max jump we need to increase we need to take one more step. Then only after just after calculating the maximum jump we'll increment the number of steps from the previous value to one more, right? So what is done, which is done here. Okay, so now let us inspect this range. What is the maximum value that you can reach from here? we already are index 1, and then we can make a jump of 3, which is at least, which is 4, so we can reach from here to 4. Nice. And then for this index we can take a one jump, so we can reach from here to 3. So in between this and this, we see that this is the maximum, so we'll be taking this value. So that means for this range we can reach a maximum value of 4, right? And obviously we need to increment the number of steps to 2, right? And then we check whether this maximum value is greater than equal to the value that we want to reach, which is actually 4, right? So we have reached our answer, and then we will basically return the number of steps, which is 2, right? So in practice what we do it is that, how so what is the route that we found in this step? The route we don't record, but from this it is very clear that the route that we found to reach the final index is from 0 we'll make a jump to 2, and then from 2 we'll sorry pardon, from 0 we'll take a jump to 1, right? And from 1 we'll take a jump directly to 4. So that is, this is the range, and that's how in 2 steps we'll be able to reach the uh, final index, that which is our goal. So okay, now I've explained you how the algorithm works, at least schematically. Now let us look at the code to see the exact same thing, and how this same thing is implemented in code, right? So okay, so obviously we'll just store the number of the length of this nums index, which basically nums index is basically this array, right? So we'll store this num index in a variable just to for ease of use, right? And then obviously if our num size is 0, then we don't have to take any steps, and if our number of size is 1, then obviously we are already at the end, so we don't need to take any more steps, so we'll return 0, right? And then obviously we are trying to make the first range, so our first range ranges from start to next. We'll keep both of them as 0, as we already have, I have explained in the video that we'll try to keep the initial range as 0. That is what you're trying to do exactly to here, right? And then obviously while true we carry on, and then since we are promised that we'll always be able to reach the final step, so we don't have to worry about whether this will go into an infinite loop. So we'll somehow be able to break, that means we'll be able to satisfy these conditions, so we'll be able to break, so this loop will always end, so we don't need to worry about this. So okay, so now we'll just initialize max jump to any value. It doesn't really matter what it is, as long as it is a small enough value, okay? And then, so in this case all values are positive, so we can basically uh, this is a safe assumption because this is the end of the range, so obviously we'll be reaching at least one, while traversing the range itself we'll be reaching to at a value which will be at least one greater than the range end. So this is a safe assumption to make as a minimum value for max jump, right? Initialization minimum value for max jump. So now we are basically going through the range and figuring out the max jump, and then we need to take one more step for this max jump, and then we check whether we have reached the final steps. If so, we'll return the number of steps, and if not, then obviously we'll move to the next range, which will start from the next value, from the beginning of the which will start from the next value uh, immediately after the end of the current range, and then it will go to the max jump. The ending of the next range will be the max jump, which is what I explained here, right? So and then we'll return the steps. So as you can see that it passes all the test cases. So hopefully I was able to explain the problem. I'll see you in the next video. Thank you.